Yes, guys. So we are doing question number 6. Now in question number 6, what we have done, the curve this one. So we are solving for x and y from the given equation. Now this curve is symmetric to both the axes, or is symmetric about both the axes of x and axis of y. Why? Because the even powers are there for both variable x and y. So trace the curve. X square minus a square and y square minus b square equal to a square b square. Okay, so now we solve this by multiplying these two functions or factors, and after that we have obtained these values. Y square equal to x square, this one. Y square equal to, from these two we have taken common y square, x square minus a square is in the denominator. Okay. Now, what is the possibility here? If I substitute, in this case, x is defined. Okay. Now, all right. So this equation is here y square is negative. Y square is negative. Here y square is negative. For x, if value of x square is less than a square, that means less than a. If x is less than a negative value, then y square is negative. Y square is negative for values of x. If x is less than or equal to, or if it is x equal to plus minus a, for example, or that we will do later, but x equal to, if less than a, if x is less than a, that means this value, then this will be negative. Okay, so if x square, whatever the value, numerical value of x comes out to be less than a or a square, then it will be negative. In that situation, y square will be negative. If x is not equal to, x is less than a, then y is, it means for negative values of x, y square is negative. Okay, for negative or positive values. So, but at x equal to, if we take value of x is not defined, y square is not defined for x equal to a here. So x is not equal to a, as a is not defined, y tends to infinity, at x equal to a here, as y tends to infinity, as x equal to, as x tends to a, as x tends to plus minus a, or x tends to plus minus a, or x tends to minus a also, even then y tends to infinity. It means we have to just find out the absolute roots here. Okay, in that situation, if I just solve this question, so x y square equal to this value. Now, if I shift the origin, because origin is here, origin is not the function is not passing through the origin. Okay, so function is not passing through the origin. So equating the coefficient, if I find out the tangents here, so 0, 0 is not the origin here. X equal to plus minus a, and y equal to plus minus this, x equal to plus minus a, and from this x is negative for y if y is equal to b. Similarly we can argue here. Similarly, arguing for x square is negative from this second equation. X square is negative for y equal to, y square is equal to or is less than b square. If y square is less than b square, that means negative value, or y is negative, y is less than b here, plus minus y square is less than b square. If we say, or y is less than b, plus minus b, y cannot be equal to b here, because then x is not defined. So y is not equal to b, as x tends to infinity when y tends to a and y tends to minus a. Both y tends to minus a and this cannot be equal. these values cannot be equal. What are those asymptotes? For asymptotes, these values are there. Now for asymptotes, if I find out equating the smallest degree terms from the given equation, okay, so this is the condition here. I'll just draw the figure, but before that let me solve this question. Okay, let me clear this by this figure. Okay, now if I equating the smallest degree terms, finding the tangents, equating the smallest degree terms to 0, we obtain x square minus a square equal to 0 and y square minus b square equal to 0. This implies that x equal to plus minus b. We will take this now. X equal to plus minus a and y equal to plus minus b from this one. So it means, but y cannot be equal to a minus a and plus a, but they are distant to go. They are the asymptotes here, but these asymptotes will not have the same values. I mean, they cannot be equal to a and b because at a it is not defined. Y square is not defined here, as we just did. The y square was not defined when x equal to a or minus a. So the asymptotes are x equal to a and y equal to a, but the value is not equivalent to a. What the figure then? The figure will be, let me just take, what is the tracing of the curve here in this case? Let me find out the tangents here of this curve. Okay, these are the x-axis and y-axis. This is x-axis here, and this is y-axis, origin here. Now, tangents are, okay, here are the asymptotes here. Asymptotes are x equal to minus a, x equal to plus a, y equal to minus a and minus b, and y equal to plus b. But values are not equivalent to a and b. So these, if I draw y equal to a, y equal to b here, let me take this with b. Why this dashes are there? Because y cannot be equal to b, because at y equal to b, the x square is not defined, x tends to infinity at that situation. So this is y equal to b here, y equal to b plus b. Similarly, y equal to minus b, which is also not defined. When y equal to exactly b, then x square tends to infinity. At that situation, if y equal to minus b, this is the straight line, y equal to minus b, but the asymptotes are not defined. Okay, and similarly, as we have just said that when x is less than or y is less than a, b, and x is less than a, within this period, because then x tends to infinity, sorry, minus value, y square tends to negative for x equal to a, negative and positive. Okay, so for this negative and positive value, this one, let me take here x is equal to a, x equal to a here, this is the line, x equal to a, okay, and this, similarly x equal to minus a. So within this area, the curve is not defined. Okay, so their curve tracing will not be possible within this area. What is the reason that x equal to minus a? X cannot be equal to minus a, so we have taken this dotted line. But when x tends to minus a, then y square tends to infinity. So what are the asymptotes here? Or y square was negative for x equal to a and x equal to minus a or plus minus a, but x cannot be equal to a or minus a. So we have taken this area because y square is negative or imaginary. In that case, the curve cannot be traced in between this. What is the asymptotes here? At asymptotes will be when x tends to minus a x tend to minus a, or if I take this just asymptote like this, no problem. This is the asymptote which is when x tend to 0 to minus infinity, or this minus a to infinity, minus infinity. Beyond minus a, I mean minus a to 0, 0 to minus a, the figure is not defined. I mean the tracing of the curve is not possible, because that is not possible here. Similarly, from 0 minus a to plus a, curve is not there. Similarly, from minus b to plus b, the curve cannot be drawn because the x square is negative then. The x square is negative, for that is imaginary. So tangents are imaginary for these values. So this period will not include any curve trace. Similarly, the second asymptotes, because the curve is symmetric to both the axes. So this is symmetric to x-axis, we say x-axis symmetric, and y-axis symmetric is this and this, y-axis this and this, y-axis. Similarly here, curve asymptotes like this situation will be here. So here also curve tracing. Okay, so this is another curve here. So this is the tracing of this curve. The reason is why these tangents are, for these straight lines are not included, these asymptotes are not included. Why these asymptotes are not included? Because when x equal to y equal to plus b or y equal to minus b, then x square was not possible, not defined. I mean that was tends to infinity. When y equal to b or y equal to b and y equal to minus b, the x square is not defined. X square tends to infinity. X square tends to infinity. When y from minus b to plus b, this is plus b here, y equal to plus b. Beyond plus b, because less than b or minus b to plus b, this is minus b to plus b, the y is not defined, so the x is not defined here, x cannot have values. So this region will not have any tracing of the curve. So the asymptotes, in this case, asymptotes are this: when the x is increasing from minus a to plus this plus a to infinity, then y is 0 to infinity, okay, or this is from 0 to infinity here. Y tends to infinity when x is tends to a to infinity, or a to this 0 to a. If it is 0 to a here, then y tends to infinity 0 to this b to infinity. So this is how this figure is there. Tracing of the curve of question number 6 is of this kind. So what is the possibilities we have taken? The curve is symmetric to both the axes. Then 0, 0 is the origin, okay, no problem. Then 0, 0 is the origin here, or curve is not passing through the origin that we have taken. Okay, origin is only 0, 0. But then we found out that the solution of these values, I mean x square y square, here the tangents here, so tangents are x equal to plus minus a plus minus b. Here the tangents here, but these tangents are not equivalent to value, because x cannot be equal to minus a and plus a, otherwise y square tends to infinity. Or these points, at these points asymptotes are possible. These asymptotes we have drawn here, but these dotted lines shows that x cannot, y cannot be plus b, y cannot be plus b, but it is equivalent to b. We have taken dotted line here. Okay? This is the curve tracing of question number 6. Now let me take 7th question here. What does question number 7 say? Let me check it. Question number 7 now. Question number 7, what does it say? Let me check it. Okay, question number 7. Question number 7. Okay, so what did it say? Now the equation of the curve in case of 7th question we are given here. y is equal to this x square plus 1 into x square minus 1. This is equation number 1. Okay, so what is given to us here? If I find out the solution, now this equation is symmetric to first solution. The equation is symmetric to y-axis. Why? Because x square is even. Here, first point. Here the powers of x are even. So the curve is symmetric. So the curve is symmetric to y-axis. Is symmetric to y-axis. If it is symmetric to y-axis, putting x equal to 0, what do we get? Putting x equal to 0. But if it is symmetric to y-axis, then we put x equal to 0, x equal to 0, 0, y equal to minus 1 here. So y equal to minus 1. Y equal to minus 1. So what is the point? It means the curve is passing through the point 0 and minus 1. Because the 0 and minus 1 is one of the points here to which curve is passing. Okay, so this is now shifting the origin to this point. Shifting the origin to the point. It's a double point here, 0, 1. We get this equation is turned to y minus 1 is equal to same value x, because x plus 0 is nothing but x square plus 1 into x square minus 1. Okay, so from this equation, what do we get? If I equate the coefficients, the smallest degree terms of this equation to find the tangents here, this is the equation. Equating. Okay, now equating the smallest degree terms to 0. What do we get here? Y minus 1 equal to 0. This is the, because y equal to or y equal to 0 here. So y equal to 0, that means x-axis, sorry, not y, but y equal to 0 here. Y equal to 0, that means x-axis, the new x-axis, is the axis of the curve. The new x-axis at the shifting points at the origin or at the new origin 0 and minus 1 will be the axis of the curve, the axis of the curve. So 0 minus 1 we have to, or this, it means this is the new x-axis is parallel to the old axis. The new x-axis is parallel to the old x-axis of x. Okay, that we have to say that what is the curve here, and y equal to 1 is one of the axes here. Y is equal to 1. Y is minus 1. From this equation we find here that y minus 1 equal to 0. So we just equate, and x is equal to plus minus 1. X is equal to, if I solve this equation, what do we get? Y equal to 0 is the equation of tangent line. That means y equal to 0 is at x-axis. X-axis is the tangent line here. Okay, so that tangent line we put down. one thing. Then secondly, that what is the solution if I find out from this equation, so x square equal to 1 or x equal to plus minus 1. That means x equal to plus 1 and y x equal to minus 1. They are also the values of the function here, because y is not defined here for x equal to plus 1 and y equal to or x equal to minus 1. That means y is negative. So x equal to 1 and y equal to 1 from the original equation. For x equal to plus minus 1, y is negative. Y is or x equal to plus minus, I'm sorry. If x is less than minus 1, then for y equal to plus minus, y is 0, not negative. If it is 0, then y is 0 here, not negative, but y is 0. Y is 0. But for x less than minus 1, x less than minus 1, y is negative. Y will be imaginary for f if x is less than minus 1 from this equation, or plus 1, because if it is 1 here, minus 1, x square numerically less than minus 1, you can say. If it is less than minus 1 or x square is numerically less than minus 1, then y is negative. So the curve will not exist. The curve will not exist between x equal to minus 1 and x equal to plus 1 as well. Between x equal to will not exist between x equal to minus 1 or below minus 1, 0 to minus 1. We cannot say that curve is line. So if it is minus 1 here, 0 and 0 also, or 0 also, the value will be negative. 0 to minus 1 is not equivalent to minus 1, but is this value is less than minus 1. The curve will be negative or will not. Okay, so the curve will not exist here. The curve will not exist between x equal to minus 1 to 0. 0 here. Okay. So what is the in the first situation? This one 0 minus 1 is the new origin. So that we will shift, then draw the line to one curve is, and curve is symmetric to y-axis. That is also to be taken into consideration that we discuss about. Because y equal to minus 1 from this equation, y equal to minus 1, that we have taken the point, the shifting point, this one. What is the curve of this kind? Let me take the tracing of the curve now. What type of curve tracing will be here? First of all, this is y-axis here. So one of the points is this minus 1, 0 and minus 1. So through this, if the curve is passing, this is one of the curves here. Okay, and x equal to minus 1 and x equal to plus 1. And this is the plus 1 here. So this line x equal to minus 1 and plus 1, because between these two lines the curve will not exist. X equal to minus 1 and plus 1 also the same value, because if it is less than minus plus 1, then the value will be negative. So in this period the curve is not line. And y equal to minus 1 here, this is minus 1. So this is the new origin sequence. So this, if I take here the new axis of x, which is parallel to this axis, original axis x-axis, this is origin x-axis, this is y and y-axis. This shifting 0 minus 1 is this new origin. Okay, and the axis of x that is passing through this point is the new axis of the origin, or the new axis of the this origin 0 and minus 1, so which is parallel to the old x-axis. This is that line. Okay, so this is one of the curve here after shifting. The original curve is x equal to minus 1 plus 1, but at this what is x equal to plus minus 1? That these two lines we have taken x equal to 1, this is x equal to 1 and x equal to plus 1, minus 1. So between minus 1 and plus 1 there is no curve tracing, but this curve tracing is here because this is symmetric to y-axis. So what is the next curve here? Second curve is we have to take that x equal to below minus 1 at that y tends to infinity. When y tends to infinity, if I solve this equation, so, and after shifting that origin, we have taken this point here. Okay, so shifting that origin to that point, we'll find out that x equal to y equal to 1 here. When y minus 1 we solve after solving this equation, y minus 1 equal to that value. Okay, for that, so y is equal to 1. That means y is equal to 1 is this one line. This is y is equal to 1 here. But y minus 1 equal to, it was x square plus 1 into x square minus 1. After shifting that origin to this, okay, 0 and minus 1. And the curve was y minus 1 equal to 0 or y minus 1 equal to 0, so we obtained y minus 1 equal to 0. So this was y equal to 1. No y equal to plus 1, sorry, minus 1. No below or straight line y equal to minus 1 is not there. Only y equal to plus 1 is there, or is possible. So what are the other, asymptotes here? Then we found out the asymptotes, that in the position when x tends to x is from 0 to minus 1 to minus infinity, then y tends to infinity. This is the curve here, asymptotes here. You can take the asymptotes here, and this is under asymptotes, because when x tends to 1 to plus infinity, then y tends to infinity. Okay, and these two are symmetric to the axis of y. Axis of y of curve is symmetric to the axis of y here in this case, and this is the shape of that curve. Here it is angle after shifting the origin 0 to minus 1. This is angle curve which is also symmetric to the axis of y. The axis of y is the axis of symmetry here. So symmetric curve is symmetric to the axis of y. Here also the asymptotes are this, but when x tends to, it was minus 1, because then when 1 to above the value 1 to infinity, positive infinity, y tends to infinity. Okay, that we have taken here. Y tends to infinity when x tends to, x is more than 1 to this. When x increases from 1 to infinity, then y is 0. Y tends to 0 here. 1 to infinity, then y tends to 0, or this is y tends to infinity. Y also increases. And this is the value. So they are the two asymptotes here. Question number. So this curve and these two curves are symmetric to the axis of y. That we have taken here. Okay, number 2. Okay. Tested here. Okay, so I have taken this curve here. Alright. Next question is 8th one, which I sorry. Now question number 8, what does it say? So this is the curve of the question number 7, which we have taken here, where that x equal to y is equal to 1 here, so y equal to 1, and the other two asymptotes just similar. Okay, so this we have taken question number 7. Now, what is the question number 8 here? Let me take question number 8A. 8A and 8B both are similar type, but let me find the difference. What is the difference between them? Okay, so question number 8A and then question number 8B we will discuss about. But before that, let me get this. Now, question number 8A, what is the question? What is the tracing of this curve? Let me trace that. Okay, question number 8A, the same trace the curve x cube minus x y square. This is question number 8a. Okay, we have taken this in the curve. This is x cube minus x into y square plus a into x square plus y square is equal to 0. Okay, this is the curve here. The equation of the curve, not solution. Now this equation is it symmetric or not symmetric? Let me check. Okay, so here y square is even, so the curve will be symmetric to x-axis. Here, one thing, the curve is symmetric. Curve is symmetric to x-axis, about x-axis. This is about word. I'm sorry, about x-axis, as y is even power, as powers of y are even. Powers of y are even, so curve is symmetric to axis of x. Simple question. Okay, what we do? We put x equal to 0. What do we obtain then? Value of y. Putting whenever the curve is symmetric to x-axis, so we put x equal to 0. Symmetric about x-axis, so we put y x equal to 0 here. Or if we put y equal to 0, because it is symmetric to x-axis, putting x equal to 0, we obtain what? 0, 0, 0. So y square equal to 0. Y is equal to 0 or y equal to 0 and y equal to 0. So these are two tangents here. Y equal to 0 and 0. Okay, so 0, 0 is again 0, 0 is lying on the given axis, because all terms are there is no independent constant term. So 0, 0, the curve is passing through 0, 0. The curve is passing through 0, 0. Second point, the curve is passing through 0, 0. Okay, the curve is passing through or 0, 0. The origin is lying on the curve given. One thing. Now, if I shift to the 0, 0 is okay shifted. Now, if I equate the smallest terms, equating